Hey guys, welcome to your Algebra 2 lesson 5.1. Today we're going to talk about using properties of exponents, and I think we're going to do it all on one video. So our objective is for you to be able to simplify expressions involving powers. So here are some properties of exponents. If a and b are real numbers and we let m and n be integers, the product of powers property, if you've got the same base and you're multiplying powers, so if you have a to the m times a to the n, that is going to equal a to the m plus n power. So that little underline there, the m plus n, that's the exponent. So a to the m times a to the n equals a to the m plus n. Now, if we have a power of a power, or power to a power, you're going to multiply your exponent. So if you have a to the m, the whole thing raised to the nth power, we often say a to the m to the n, we multiply our exponent. So we get a to the m times n. Now, if we've got a power of a product, so in other words, we have something like AB, and AB, the whole thing is being raised to the m power. We can take each factor in that product and raise it to the power. So we have a to the m times b to the m. Now, our negative exponent property, we have a to the negative m. That negative really means reciprocal. And so what this actually means is 1 over a, the whole thing to the m power. But since 1 to the mth power is just 1, we can write this as 1 over a to the m. And that really is the simplification of 1 to the m over a to the m. If you're confused about that, please feel free to ask me in class. But it does eventually equal 1 over a to the m, so long as a does not equal 0, because we can't divide by 0. The zero exponent property is that anything other than 0 to the 0 power is 1. So in general, any number to the 0 power equals 1. The only exception is if the base is 0, and then it's undefined. 0 to the 0 power is undefined. Okay, quotients of powers property, we have a to the m divided by a to the n, and that's going to equal a to the m minus n. Again, a can't equal 0 because we cannot divide by 0. And then power of a quotient property, if we have a over b to the mth power, you raise the numerator to the mth power and the denominator to the mth power. So that's going to equal a to the m over b to the m. And so b is not equal to 0 in this case because, again, we can't divide by 0. Okay, so the first thing we want to be able to do is evaluate numerical expressions. So our first example, we've got negative 4 times 2 to the 5th squared. So the first thing we're going to do is the power of a product property. In other words, we're going to raise both of those factors to the second power. So we're going to take negative 4 and we're going to square that. And then we're going to do 2 to the 5th and we're going to square that. Now there's other steps you can take, but these are going to be the steps that we take as we work through this problem. So we've got negative 4, the whole thing squared. So negative 4 times negative 4 is positive 16. And then we've got 2 to the 5th squared, so we want to multiply those exponents because it's a power to a power. So we'll have the 16 from the negative 4, the whole thing squared, times 2 to the 5 times 2. 5 times 2 is 10. So we have 16 times 2 to the 10th. So what you do now is you would do 2 to the 10th and then multiply by 16, and that's going to give you 16,384. Okay, for part B, we've got 11 fifths over 11 to the 5th power over 11 to the 8th power, all raised to the negative 1 power. Remember that negative 1 means, or a negative means reciprocal. So we can flip the 11 to the 8th power and the 11 to the 5th power, and then raising something to the first power doesn't change it. It's just the same thing. So this actually combines a couple of steps. So we've got 11 to the 8th power over 11 to the 5th power. And now we use our quotient property where we subtract the exponents. So we have 11 to the 8 minus 5. And so that's going to give you 11 cubed, which is 1,331. One of the most common uses of all of these properties of exponents is in scientific notation. A number is expressed in scientific notation if it is in the form c times 10 to the nth power, where 1 is less than or equal to c is less than 10, and n is an integer. So we're going to use scientific notation. A swarm of locusts may contain as many as 85 million locusts per square kilometer and cover an area of 1,200 square kilometers. About how many locusts are in such a swarm? It's a lot of locusts. Well, for our solution, we're going to take the locusts per square kilometer and we're going to multiply by the number of square kilometers. So we're going to have 85 million times 1,200. We're going to write this in scientific notation to make it a little easier. 85 million in scientific notation is 8.5 times 10 to the 7th, because we'd have to move the decimal over 7 places. And 1,200 is 1.2 times 10 to the 3rd power, because we have to move that decimal over 3 places. So now we are going to use multiplication properties to multiply the 8.5 times the 1.2, and then we're going to multiply the 10 to the 7th times 10 to the 3rd. 8.5 times 1.2 is 10.2. 10 to the 7th times 10 to the 3rd, that would be 10 to the 7 plus 3, and so we would have 10 to the 10th. And we're just using our product of powers property, where if you have the same base, you add, and you're multiplying, you add the exponents. So now we just have one more thing we need to do. Remember, for it to be in scientific notation, that first number, that C value, has to be between 1 and has to be less than 10. So between 1 and 10, not including 10. So 10.2 is too big. We need to write that as 1.02 times 10 to the 1st. So if we write 10.2 in scientific notation, that's equal to 1.02. We move the decimal over 1 place, so it's 2 to the times 10 to the 1st. So we'll have 1.02 times 10 to the 1st times 10 to the 10th power. So we need to use those the products of power property again, where we've got the same base of 10, so we add the exponents together, and so we'll have 1.02 times 10 to the 11th, and that's our answer in scientific notation. Okay, so the number of locusts is about 1.02 times 10 to the 11th, or 102 billion locusts. That's a lot of locusts there, guys. All right, simplifying expressions. You can use the properties of exponents to simplify algebraic expressions. A simplified expression contains only positive exponents, no negative exponents. So we've got b to the negative 4 times b to the 6th times b to the 7th. So we're going to use the product of powers property. So we're going to add all those exponents together. So we'll have b to the negative 4 plus 6 plus 7. So that'll be b to the 9th, and that's it. On this next one, we've got r to the negative 2 over s cubed, all raised to the negative 3 power. Okay, we're going to go ahead and use the power of a quotient property, and so that means we're going to have r to the negative 2 raised to the negative 3 power, and we're going to have s cubed raised to the negative 3 power. So now we're going to use the power of a power property, where you multiply your exponents whenever you have one base raised to one power and then to another. So we'll have r to the negative 2 times negative 3 is positive 6. And then we have s to the 3 times negative 3, so that's s to the negative 9th power. Now we're going to use the negative exponent property, and so that gives me r to the 6th over 1 over s to the 9th. Now, when you have r to the 6th divided by 1 over s to the 9th, you're taking something and dividing by a fraction, so you multiply by its reciprocal. So we'll have r to the 6th times s to the 9th over 1. So we have r to the 6th times s to the 9th. So a shortcut is, see this s to the negative 9? If it's already written in a fraction, you can get rid of that negative by changing levels. So since the s to the negative 9 is on the bottom, it can come up here to the top with the r to the 6th, and it'll be s to the positive 9. That's just a little shortcut to save you a step if you'd like. All right, so I've got 16m to the 4th times n to the negative 5 all over 2 times n to the negative 5. So the 16 over 2, we just divide to give us 8. And then there's nothing to combine with the m to the 4th, so it's going to stay. But then we use the quotient of powers property to do n to the negative 5 minus the exponent on the bottom. Well, on the bottom we have another negative 5. So this negative 5 is from the top, and then minus because of the division, and then this negative 5 goes right here. Well, that's going to be negative 5 plus 5, because minus a negative is the same thing as adding a positive, so we're going to get n to the 0. So we have 8m to the 4th times n to the 0. Well, n to the 0 is going to be 1 so long as n isn't 0, which it can't be because it was down here in the denominator anyway. So n to the 0 is 1, and 8 times m to the 4th times 1 is just 8 times m to the 4th. Okay, example 4. What is the simplified form of x to the negative 3, y cubed, the whole thing squared, divided by x to the 5th times y to the 6th? Okay, so write down the original problem. And we're going to use power of a product property, which means we're going to square both the x to the negative 3 and the y cubed. So we've got x to the negative 3 squared, y cubed squared, and then our denominator, x to the 5th times y to the 6th. And we're going to use power of a power property, so we're going to multiply the negative 3 and the 2 right here, because we've got a power of a power. So we're going to have x to the negative 6, and then we're going to have y to the 3 times 2, so y to the 6th. Okay, so we've got x's on top and bottom, y's on top and bottom, so now it's time to use the quotient property. And so we'll have x to the negative 6 minus 5 times y to the 6 minus 6. So that's going to give us x to the negative 11 and y to the 0. Y to the 0 is just equal to 1. So we've got x to the negative 11, but we don't leave negative exponents in a simplified answer. So we apply the negative exponent property, and that gives us 1 over x to the 11th power. And then we're done. So the correct answer is B. Choice B. All right. A real life example here. We're going to compare volumes. Betelgeuse, and yes, that's how it is pronounced. I looked it up. Betelgeuse is one of the stars found in the constellation Orion. Its radius is about 1,500 times the radius of the sun. How many times as great as the sun's volume is Betelgeuse's volume? Okay, so if we let r represent the sun's radius, then 1,500 r represents Betelgeuse's radius. So we're going to compare. We want to know how many times larger Betelgeuse's volume is to the sun's volume. So whenever you're asked to do that, you're always asked for the ratio there of one to the other. So let's set it up. Remember, the volume of a sphere is 4/3 pi r cubed. So for Betelgeuse, that's going to be 4/3 pi times 1,500 r cubed. And the sun's volume, we're just using 4/3 pi r cubed because we're letting r represent the sun's radius. Okay, so we're going to use the power of a product property. So that means that we'll have 1,500 cubed times r cubed. Let's see, the 4/3 cancel, the pi's cancel. We can do the quotient of powers property. We had r cubed over r cubed. Really, you can just cancel them, or you can do r to the 3 minus 3, which is r to the 0. So we have 1,500 cubed times r to the 0. R to the 0 is just 1. And then we just do 1,500 cubed, which is 3,375,000,000, or about 3.4 billion times billion is the ratio between the two. So Betelgeuse's volume is about 3.4 billion times as great as the sun's volume. That's big. All right, guys, that's it. You're ready to try the problems on your own, and then we'll be ready to do the rounds. Okay, go ahead and get started on those problems to try on your own, and then we will do the rounds.